everybody. In this video, I want to talk about De Morgan's laws. So we've actually gone over these already, but I think they're a little bit hard to internalize unless you get a little bit more practice with it. So when I ask you to tell me what the two De Morgan's laws are, I'm basically expecting you to say not x and y is equivalent to not x or not y, and similarly not x or y is equivalent to not x and not y. Okay, these are the two rules, but the question is what this actually means. I think some things that will help to explain what they mean a little bit better is visually, if you like Venn diagrams, I think those help to draw out. And another thing that you can do is draw out a truth table and convince yourself that De Morgan's laws are really correct. So let's go ahead and do that. So the first thing that I'm going to do is I'm going to create a truth table. And I'm going to say, I'm going to check x and y, then negate the whole thing to get not x and y. And then what I'm going to do is I'm going to create another truth table, x, y, not x, not y, and then we're gonna see what not x or not y are, and we're actually gonna see that they're equivalent on every row. So let's just go through with each of these. This is going to be 0, 0, 0, 1, 1, 0, and 1, 1. And then, of course, on this lower table, it's also 0, 0, 0, 1, 1, 0, and 1, 1. Those are my four choices that I have with two Boolean or binary values. So I could have also filled this in with true or false. It's up to you, really. So let's go through with the and since as long as there's a 0, the whole thing will be 0. So these are all 0, and only 1, 1 evaluates to 1. Good. Now I'm going to negate everything, so that's going to give me 1, 1, 1. And right here, this is actually going to be 0. If you notice, this actually starts to look similar to an OR because you would kind of expect it to have 3 1s in it and 1 0. But let's continue. What we're going to do now is we're going to go to the second table, and I have 0, 0, which is going to become 1, 1, then 0, 1, which is going to become 1, 0, 1, 0, which is going to become 0, 1, and then 1, 1, which becomes 0, 0. So I hope it's clear here that I just flipped whatever x and y were. And now I'm going to go through and do the OR. 1, 1 is 1. This has a 1 in it. This has a 1 in it. And this one is both zeros, so this is 0 as well. And you'll notice, hey, these are exactly equivalent on every line. And because of that, you conclude, hey, De Morgan's law is telling me not x and in parentheses x and, not in parentheses x and y is equivalent to not x or not y. You should go ahead and give it a try with the other law. So another way to think about ands and ors is just with a Venn diagram. If I wanted to do x and y, just x and y, what happens is that x and y, they both have to be true, means that you live inside this section here, the intersection between the two items. Meanwhile, if you have x or y, then only one of them has to be true. So you can have, basically, you would either have that x is true, which is the whole world of x, all of y is true, And then, of course, in the center, this can also continue to be true for both of them. Okay, so that's what and or actually mean in terms of Venn diagrams. Now, you can actually end up drawing little pictures to show that De Morgan's laws also work using this Venn diagram if you're visual like that. So we can give it a try. So let's work through the rule of not x and y is equivalent to not x or not y. And we have our two Venn diagrams. We just basically want to prove that they're going to color in the same regions. Okay, so we learned previously that x and y indicates the region that's in the intersection of both of them. So this is the part that is not included for not x and y. So it's everything else. So I can do maybe a little star to show that it can be here inside the part that's y but not in the intersection, the part that's x but not in the intersection, and then also it can be out in the world of things where neither of them are true. And then let's look at not x or not y. So where not x is true is, well, anything out in the world, and as well anything that's inside y that's not inside x. Okay, and then for not y, well, where is that true? Y is not true outside in the world, and anything inside x. So we end up seeing that basically these regions that are kind of colored in are the same in both. And you can actually tell, if you that basically this part that's in the intersection is also not going to be included. Right? So you can conclude using Venn diagrams as a way of convincing yourself that these two rules are really equivalent. So just to conclude, we talked about De Morgan's laws. And there's basically just these two rules that basically tell you how to distribute and not. And you can convince yourself that it's true via truth tables, especially if you can't remember what they are. And you can also convince yourself using Venn diagrams. I would maybe suggest that you can actually use truth tables as an exam technique or a homework technique. Over and over again because they're pretty quick to write out. The Venn diagrams tend to take a little bit longer, so this is maybe really only for convincing yourself. And maybe not using all that often just because it would be time consuming to draw them out. I obviously did it very quickly, but sometimes it takes a little bit to visually see where things are being colored in. And you probably need a couple of different colors to actually manage it clearly. So it's a little bit inconvenient to do so. But, if you like it, you can use it. And I guess one more thing to note is use any variables you like. So you can use x and y like I did, or if you like a or b, or if you like to write out whole words, that's also fine. Just probably you don't want to use t and f because they may mean true and false. But using any variable names, if some letters click with you better, that's totally fine with me. And it will help you, if it helps you remember what's going on with De Morgan's laws and understanding what they're doing, then I approve totally. I hope this video helped you understand De Morgan's laws a little bit more clearly. And please do take the time to draw out those truth tables and convince yourself that it really does work, or the Venn diagrams. Thanks for watching.